Hi everyone, my name is José Hidasi, and I'm here to give you a brief introduction to our language. So let's go. First, we have to ask ourselves, what is an algorithm? So, to understand an algorithm, we have to think about some sort of recipe to do something. So in this example here, we get first an input value, uh, that is the age of someone. For example, my age is 29. Then in the second step we add 1, so 30. Then we divide by 2, so 15. And then we have the output. We return the value, in this example, 15. So this is an algorithm. We have steps to follow in relation to an input value that will then become an output value after these steps. And okay, so we know that we have algorithms that we want to create to solve problems of everyday life. But we can do that using lots of programming languages. We have we have languages like C Sharp, Swift, R, Ruby, Python, JavaScript. Which is the best one? So it depends on what you want to do. For example, the first programming language that I used was JavaScript. I wanted to make games when I was young. So to create my RPG games, I learned uh, alone a little about JavaScript, and then I created some RPG games using the famous software RPG Maker. C Sharp is also a language that I know a little, and it's also um, it also aims at games. For example, I have a game published on the Google Play Store, and it's called Cerrado Runner. You use Cerrado creatures to run away from the fire and get some coins to buy your friends. Also, you have Python. That is what how they say here is general purpose coding language. So we can make also games using Python. For example, using the package or module called Pygame. This is a game called Migrate that I created. You control the arrows, so you guide the bird and get insects along the way until you can't guide it anymore, or lose your attention and let the bird fly away. And you have a language that is 100% or almost this value of percent to related to data science. But what is R? R is a software and a programming language, or we can say that it's a programming environment. So what do you use R for? We use it to do a statistical analysis and graphs. And if you're an adventurer, you can make games. I promise that I will show you a game that I made in R. So pay attention. Uh, Here's a brief history of R. First, in the 50s, some researchers created the language Fortran. A few years later, in the 70s, they created the C language, and Nokia Bell Labs created the S language first, using Fortran as a base language, and then they transformed it into the C language, the base program language into C language. So S based on Fortran and S based on C. Then Ross Ihaka and Robert Gentleman at the University of Auckland, they used the S language based on C to create the R language in the 90s. Okay, but why to use R? Can't we use, for example, the Python environment? Yes, we can, but R is free and open source. Python is free and open source too. R is easy and fast. Is an easy and fast language. Python is too. You can create and edit your functions. You can make this on Python too. But R is really easy to plot graphs. It's a powerful tool to plot graphs, and it's used in several areas of knowledge. So you can use it in economics, ecology, biogeography, geography, and so on. And why should not use R? First, the loops or iterations in R are very slow in comparison to other languages, and it's less efficient to manipulate big data in relation to the SQL language that was basically created for that. Okay, but let's take a look at the loops here. If we have a program that is running on C language, if it runs in t equals 1, R runs the same program at t equals 23. So that's a very different runtime in relation to C language, isn't it? But uh, although we use R because it's easy, it's used on different areas in different areas of knowledge, and everyone is will eventually know R a little. Then and who uses R? Google, Pfizer, Merck, Bank of America, Windows, and in relation to Windows, they even have their own iteration of R, the Microsoft R, that we will see. So we have we will see now how to install R. To install R, it's very easy. We basically go to our website. We can use the R the basic our software website, or we can use the Microsoft R. I really say to you that Microsoft R is a better iteration of R in this right moment, and it's fast, and it has help for their functions. It's um, you can use it in with multiple cores in mind. So it's faster than the basic version of R when talking about Windows. Okay. So let's understand a little about the interface of R. We have the console screen, that console window that we use to do things, so calculate things, create objects, and so on. So that's the screen, that's the window that we will use mostly. We can have a script screen, a script window that we can use inside R, but I don't recommend it. It's better to open a notepad just like that. You open R, and then you open an empty notepad and make your script. Okay, so do like that, because if something goes wrong and when you're running R, you lose everything. So returning to our presentation, and we have a plot, a graph window. When we create graphs, when we type the functions to create graphs, they appear in the plot window. So let me show you an example. So plot 1 to 10, 1 to 10. So uh, it will then appear a new window with our plot there. Okay, so that's how R works for graphs. And let's understand a little about RStudio. What is RStudio? It is a graphical interface for R. So uh, there's a lot of people that use RStudio, like NASA and Walmart, but it's basically R. When you if you see that here, before using RStudio, we have the R running, and after the RStudio, we have here the RStudio. So what's the difference? That we have everything in a single interface, and it's, if you want to use it, it's with you. You choose if you want to transform your interface into RStudio. I really prefer the classic version of the interface. I really prefer to not use the RStudio, because if something goes wrong when using the RStudio, you lose everything. If something goes wrong when using the classic version of R, you only lose the application that is R, and your notepad will be saved, or even the other things that you're using. Okay, so using R. First, we can use R to create objects. What is an object? For example, if you use R and type x equals 1, so x will be equal to 1, and x equals to 2, you x x will be equal to 2. If y is equal to x, this pay attention that this arrow that we draw is just the equal sign. Okay, so if y is equal to x, y will then be equal to 2, because we transformed x into 2. And if we say that z is inside commas equal to some word like word, or palavra, that means word in Portuguese. So z will be equal to palavra. We can repeat that here. X equal to 1. If we type x and press enter, we will see that x equals to 1. And if y equals to x, y will be equal to 1. Okay, then we can use arithmetic operators in R. We can use R as a calculator. We can sum values, we can divide values, we can multiply values, we can use potencies. For example, if we use 2, potency 2, 4. If we if we add 3 to 2, we get 5, and so on. And potencies are indicated by 2 asterisks or 1. We say in Brazil, jogo da velha, but this. Jogo da velha não. We say circunflexo, but just this sign. 2 elevated to 2, as I did before. Okay. Then we have the relational operators. These relational operators are used to indicate if something is false or true in relation to something else. For example, these are our symbols. We have less than, greater than, less than or equal to, greater than or equal to, and not equal to. So why do we use this equal to as two signs of equal sign? Because if we use only one equal sign, you will just assign a value to a variable. So when we use, for example, x equal to 1, so x will be 1. We are not asking if x equals to 1. We are assigning the value 1 to x. So when we use x equals with two equal signs to 2, it's false because x equals to 1. And if we say, we ask if x equals to 1, it says that it's true. Okay? So 2 is greater than 2? No, it's false. And 3 is greater than 2? Is 3 greater than 2? Yes, this is true. Okay, then we have logical operators. We have the exclamation sign, which says that logical that means logical not, and we have the logical and, that are the and symbol 2 times, and the logical or, that is this symbol that I don't know the name, 2 times. So let's see an example. For example, 2 equal 2 equals 2. Yes, that's true. But if we ask, is 2 not equal to 2? This is false. Okay? So that's how you ask this. Then we can ask, is 2 equal to 2 and 2 equals to 3. So this is false, because if we use the AND operator, we have to give 2 true arguments. So if we have this 2 equals 2 and 3 equals 3, so we have a true state. Now, if we want to use that strange symbol, for example, is, so the OR operator, if is 2 equal to 2 or 3 equal to 3, yes, at least one of them, of these arguments, is true. But is 2 equal to 2 and 3 equal to 2? True, because at least one argument is true. But is 2 equal to 1 and 3 equal to 2? No, that's false. Okay, so that's the difference it's difference between OR and AND. So 3 is 3 equals to 3 and 4 equals to 3. This is false. And is 1 greater than 2 and or 2 equal to 2? This is true, because at least 2 is equal to 2. Okay, now let's talk about structures of language, of programming languages. So we have, for example, the conditional structures. For example, if we assign the number 2 to an x variable, we can ask, can say that if x equals to 1, so x will be, we will add 1 to the x variable, else x will be equal to 4. What do you think? What will x be equal to 3, or x will be equal to 4? So let's see the what happens next. But first, we can use also the if-else function. We say that if else x equals to 2, we say 2, or that means, which means 2 in English. But if x isn't equal to 2, we say não 2. That means not 2 in English. So in the first question, we have that it's 4 because x is not equal to 2, and in the second question it's não 2 or não 2 because x equals to 4 and not 2. Okay, then we have the repetition structure. For example, the while structure. So if we assign the value 1 to an x variable, we start saying that while x equals to 10 is less or equal to 10, we print the value of x variable, and then we add 1 to that variable. Again, while x that starts with the number 1 is lower or equal to 10, we print on the screen, we show on the screen the value assigned to the variable x, and then we add 1 to x to x, and we will repeat the process until x is not lower or equal to 10. So the x variable will be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then what do you think that will be the final value of x? The 10 or 11? It will be 11 because we added 1 after we printed the value x. Okay? Then we have the repetition structure based on for. So the for structure. First we have the data that is a vector. We will understand that better later. So we have three values. The value 0, the value 5, and the value 10. Then we calculate n, that is the length of the dados or data. Uh, so what's the length of this vector? We have three values, so the length is equal to 3. Then we create a summa variable, which is first equal to 0, and then we use the for structure to begin in saying for I in y to y in 1 until an n value, we sum up the values that are in our data. So first we get the value 0 and sum it up with 0. Then we run this again with the second iteration, we get the 0 value and sum it with 5. Then we have the 5 value, the value 5. Then we get 5 and sum it up with 10. So we'll have the value 15. Then we use the 15 value to and divide it by the length of dados of data. This is called the mean. So this is an arithmetic mean done in R. So using a for structure. Then we can use vectors and matrices in R. And if we say x equal to c and and we get 1, 2, and 3 together, we'll get a vector composed of 1, 2, and 3, so 3 values. If we bind three of these vectors, we get a matrix. And if we put an word values, so words in between these values of the matrix, we will create a data frame. So we can have columns that we have words, columns that we have numbers. Okay. Then we can use functions in R. First, we can have the square root, for example, of 2. When R will return the value 1.414. If we want the sin of pi, for example, we can ask sin of pi, and it will return you. That will be equal to 0. Then we can ask for the natural logarithm of 1, that will be 0, and we can get the logarithm of 64 in base 4, and it will be equal to 3. Then we can ask for help for functions we use in R. We can use the function apropos to search for similar functions with a specific name. So, for example, if we use apropos mean, it will return call means, k means, mean, lots of functions to ask for help about. So when we have a name to search for help, we type help, and inside we use inside commas we say the name of the function, for example mean, or we just ask an interrogation symbol and the num the 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 word, the name of the function, for example mean, and it will return for you a help page, a help screen with saying the description of the function. In this case, it's the help for the mean function. So it calculates the arithmetic mean. The usage, you only type mean, and inside the we use the argument that is x, which can be a vector, for example, and the value is the result of the mean function, and then we have the references and see also and examples. So try to search for help for some functions at home to learn about the help function, the how help functions in R. Then we can review R's magic. So we can create a vector that has three values, like we did some steps before, with values 0, 5, and 10, and then we use the mean function to get the mean, the arithmetic mean of the vector variable, and it will return 5. So we created before the the this function, but we there is already a function in R that does that. Okay, so that's where R begin to make sense for us, because we can create functions and use functions. Not only use functions, we can create our own functions. So if we can get that steps that we did before to calculate the mean value, to create a function as we're doing here in this screen. You can see how to get the média, which means mean in Portuguese. So we ask for the média, the mean of vector, that is our data, and vector is equal to c 0, 5, 10, and we have the value 5. So we have two functions that do the same thing now. Okay, one we created, the other one is from our base functions. Okay, then we have the ability to search for packages in for the R environment. For example, if we use the library function, we can for first, if we use the install dot packages and inside brackets and uh, we put the name vegan, we will install, for example, the package vegan. And if we say library vegan, so we will load the package vegan in this iteration of R that we are using now, this session of R that we are using now. Then we can get some data and use a function that is only available in vegan package. So we get all values that are all functions that are from a package. We can get this all these functions only by installing and loading packages in R. This is very 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 powerful to work with whatever you want. And we can use graphs in R. So we can plot box plots, lines. We can use residual. Can do residual analysis for GLMs. We can plot dendrograms. We can plot maps, and we can even create our own graphs in R. So this is it by now. For now, to learn more, you can go to my website, to my blogspot, which is rfunctions.blogspot.com, and see the posts where I like to post about everything related to R. You can see how to calculate diversity, uh, species diversity. You can see how to plot maps about biogeographical patterns. You will see new functions to do things that you can't find in any place. Uh, but the blogspot. So check out the blogspot, okay? And as I promised, there's a game in our language that I made in R, and it's named Astrarium. So the Astrarium game. It's based on a game, a mini game inside Dragon Age Inquisition game that you had to link stars to create an Eulerian path. So you have an image on some in some corner of the on some corner of the screen, and you had to create this image only in a single time without uh, doing two lines at the same place, so doing Eulerian paths. So I created a function named Astrarium to create infinite Astrarium games, and this is nice because so you have an infinite source of happiness, and that's an example of how to be an adventurer and make games in a science-based language, programming language. So that's it for now, everyone. Thanks, and use R and present this programming language to everyone, and let's create a better programming environment for everyone. Okay, thank you.